Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. We are from Group 6. We will presentation about hemolysis of blood. We are first Alya Nafisah Ridwan, second Hafidzah Rahmannisa Nabila Husaeni, third Luthfiyah Astried, and the last Salsabilla Febrianti. First, we want to thank you for my lecturer, Mr. Ahmad Fahru Rozi.
Okay, I will explain about the purpose of the blood hemolysis test. This is to determine the resistance of the erythrocyte membrane to hypotonic solutions. And next, using the principle of the method is Stanford. Erythrocytes were added to various dilutions of 0.5% sodium chloride solution so that the erythrocytes swelled and had hemolysis.
Then there are tools and ingredients for osmotic presentation testing. First, we have tools. In the tools, we have test tube, reaction tube self, and drop pipette. Next, we have ingredients. The first, we have reagent, including aqueous, 0.5% NaCl solution, and in the sample, we have both at the 10%.
Okay, next procedure. The test tube will prepare as many as 12 tubes. Enter it into the tube and 14 drops of NaCl solution. Then add distilled water 0 drops until 11 drops so that it to become 25 drops. And then to each tube, 1 drop of ETA blood was added. Each tube was shaken slowly until evenly distributed. And then the tube will incubate for 2 hours at room temperature. The result of examination are read from the occurrence of hemolysis and total hemolysis.
Next, procedure. First, you must prepare sample. There are EDTA blood, sodium chloride, and aqueous. Next, you prepare as many as 12 test tubes. And the next, drop 0.5% EDTA sodium chloride solution into 12 test tubes. Next, drop aqueous into 12 test tubes containing 0.5 sodium chloride. Next, drop 1 drop of EDTA blood, 1 drop into 12 test tubes containing aqueous and 0.5% sodium chloride. And the next, each tube was shaken slowly until evenly distributed. Last, the tubes were incubated for 2 hours at room temperature.
Observation table. In the observation table, we did 12 experiments with different results. Observe change in color and also erythrocyte deposit. Giving distilled water and also natural can affect the color erythrocyte deposit and also the concentration of the solution. The more and more giving distilled water in experiment, but less and less natural solution was given.
And then, observation result. For your information, number on line 1, this is number of drops of 0.5% sodium chloride. Tube 1, 25, Tube 2nd, 24, Tube 3rd, 23, Tube 4th, 22, Tube 5th, 21, Tube 6, 20, Tube 7, 19, Tube 8, 18, Tube 19, Tube 17, Tube 10, 16, Tube 11, 15, and last Tube 12, 14. Then the next number on line 2. This is number of drops of aqueous. Tube 1, 0. Tube 2, 1. Tube 3, 2. Tube 4, 3. Tube 5, 4. Tube 6, 5, etc. Next, number on line 3. This is number of EDTA blood at droplets. Tube 1, 1. Tube 2, 1. Tube 3, 1. Tube 4, 1, etc. In the last, it's 1. Next, number on line 4. Tube 1, 0.50%. Tube 2, 0.48%. Tube 3, 0.46%. Tube 4, 0.44%, and then etc. We will tell you for this color green, this is fragility enhancement zone. Color yellow, normal zone. This blue, decreasing fragility starting zone. And the pink, normal zone, complete hemolysis. Plus is purple, fragility decline zone.
The final is observational interpretation. Lysis surfaced on 0.48% sodium chloride abnormal to phase lysis, and the complete hemolysis is abnormal 0.38 sodium chloride to phase lysis. For the maximum resistance is the total hemolysis of erythrocyte in a liquid with the highest sodium chloride concentration, a condition where the solution begins to mix with blood, but there is still sedimentation. Minimum resistance normal value is 0.32% to 0.36%. And the minimum resistance is the initiation of hemolysis of erythrocytes in the liquid with the highest sodium chloride concentration, a state where the solution begins to mix with blood, but there is still sedimentation. Minimum resistance normal value is 0.42% to 0.46%.
Discussion. The osmotic fragility of red blood cells is expressed at the level of susceptibility to rupture the blood cell membrane when exposed to hypotonic substance. When red blood cells are in the middle of hypotonic solution, water is sucked into the cell. This is due to the presence of an osmotic pressure gradient inside and outside the cell. As a result, blood cells become more spherical and membrane cells are compressed by fluid in the cell. The resistance of erythrocyte membrane to hemolysis can be determined by mixing erythrocyte into a hypotonic solution with different concentration. Hypotonic solution with a certain concentration can cause erythrocyte rupture or hemolysis. This condition is called erythrocyte fragility.
Osmotic fragility testing helps in the diagnosis of anemia in which change in the patient red blood cells are present. When the red blood cells are in the initial solution, the blood cell will absorb as much as possible until the cells swell and reach a critical volume and the hemolysis. The concentration of the intracellular solution, which is reflected by the fragility of the red cell membrane, can aid in expressing the functional condition of the cell. When erythrocytes are in a hypotonic solution, the fluid has a lower osmolality level than normal plasma or serum, less than 280 mOSN, fast kg. Erythrocyte osmotic fragility test, also called erythrocyte osmotic resistance, is performed to measure the ability of erythrocyte to withstand hemolysis erythrocyte destruction in a hypotonic solution. The method is as follows. Erythrocytes are dissolved in a saline solution with various concentrations. If hemolysis occurs in a slightly hypotonic saline solution, this is called an increase in erythrocyte fragility, or equivalent to a decrease in erythrocyte resistance. And if hemolysis occurs in a highly hypotonic saline solution, this indicates a decrease in osmotic fragility, or equivalent to an increase in erythrocyte resistance.
The next discussion is hemoglobin leaves the cells in each tube containing different levels of sodium chloride solution. The hemoglobin level was then determined by photocalorimetry. The results are reported are percentage of hemolysis. The set of hemolysis result is plotted on a curve compared to normal erythrocyte data. In a state of increased fragility, erythrocytes are usually spherical, and the curve appears to shift to the right, whereas in decreasing fragility, erythrocytes are thin and flat. The curve appears to shift to the left.
And the last discussion, this video, finally is conclusion. The osmotic fragility of red blood cell is expressed as the level of susceptibility of the blood cell membrane structure hemolysis when exposed to hypotonic substance. When red blood cells are in the middle of a hypotonic solution, water is sucked into the cell. This is caused by the presence of an osmotic pressure gradient inside and outside the cell. As a result, blood cells become more spherical and cell membranes are compressed by fluid in the cells. The resistance of erythrocyte membranes to hemolysis can be determined by mixing erythrocytes into a hypotonic solution, sodium chloride, with different concentration. Hypotonic solution of certain concentration can cause erythrocyte rupture or hemolysis. This condition is called erythrocyte fragility. Thank you for watching this video. Do you have any question? Yeah, if any question, you can comment in below. And